This week, Mother Nature unleashed her power in ways that few could have predicted, sending shockwaves across the country and reminding us all of the unpredictable force of the natural world. Across the United States, millions of lives were disrupted as communities from coast to coast faced a relentless onslaught of severe weather. The scale and intensity of these events left many scrambling to protect their homes and loved ones. In the heartland, tornadoes carved destructive paths through farmland and towns, leaving behind shattered buildings and upended lives. Emergency responders worked tirelessly, searching for survivors and providing aid to those in need. Meanwhile, in the west, deadly avalanches thundered down snow-packed mountains, catching even experienced adventurers off guard. And as if that weren't enough, a powerful nor'easter loomed on the east coast, threatening to blanket cities in snow and ice. Tornadoes tore through communities, avalanches claimed lives in the mountains, and cities braced for a paralyzing coastal storm. The nation watched as first responders, rescue teams, and everyday citizens came together in the face of adversity. These weren't isolated incidents. They were part of a nationwide weather event, each with its own story of human impact and resilience. From the Midwest to the Atlantic, the country was united by shared challenges and the determination to recover. Homes were destroyed, travel was halted, and families faced loss and uncertainty. Airports closed, highways became impassable, and entire neighborhoods were left in the dark, waiting for help and hoping for good news. Even with modern technology and advanced warning systems, our routines were upended by the sheer force of wind, snow, and shifting earth. Meteorologists worked around the clock, tracking the storms and providing updates, but the power of nature proved difficult to contain. Understanding the science behind these events is crucial, not just to know what happened, but why. Researchers and scientists are working to unravel the complex patterns that drive such extreme weather, hoping to improve forecasts and save lives in the future. By connecting the dots between climate, geography, and human activity, we can better prepare for the risks ahead. Communities are learning the importance of emergency plans, storm kits, and staying informed as weather grows more unpredictable. This week was a powerful lesson in the ever-present force of weather in our lives, a reminder that, no matter how advanced our technology becomes, we are still at the mercy of the elements. As we rebuild and recover, the stories of courage, loss, and hope will stay with us, shaping how we face the storms of tomorrow. The chaos began with severe storms exploding across the Ohio Valley, as meteorologists warned of a volatile atmosphere brewing for days. The sky darkened rapidly, and the first rumbles of thunder signaled the start of a night that would change lives across the Midwest. Fueled by a clash of warm, humid air that had settled over the region, the atmosphere became thick and oppressive, with temperatures soaring and the air heavy with moisture. Farmers and residents alike could feel the tension in the air. A familiar, but always unsettling sign that severe weather was imminent. A powerful cold front barreled in from the west, colliding with the muggy air and creating a dramatic temperature contrast. Winds picked up, bending trees and sending dust swirling across open fields as the stage was set for a major outbreak. As darkness fell, tornadoes ripped through Illinois, Indiana, and Ohio. Sirens wailed through the night, and emergency alerts blared across phones and TVs, urging people to seek shelter immediately. The sense of urgency was palpable, with families huddling in basements and storm shelters, hoping for the best. In Robinson, Illinois, a major tornado struck with little warning, prompting the National Weather Service to issue a rare, particularly dangerous situation alert. The tornado carved a path of destruction through the town, leaving homes and businesses in ruins and emergency responders racing to help those trapped or injured. Emergency managers reported a large, fast-moving tornado, and families scrambled for shelter as homes shook and debris flew. The roar of the wind was deafening, and the relentless pounding of hail and rain made it nearly impossible to hear anything else. For many, it was a terrifying reminder of nature's power. The threat soon shifted east to Indiana, where another tornado touched down near Bloomington, putting thousands at risk. Residents rushed to evacuate or take cover, while emergency vehicles navigated flooded roads and downed power lines to reach those in need. At the peak of the outbreak, over 120,000 people were under tornado warnings. Reports flooded in of snapped trees, downed power lines, and battered homes. Entire neighborhoods were plunged into darkness, and the sound of chainsaws and emergency sirens filled the air as first responders worked through the night. Hail the size of golf balls pummeled cars and rooftops, shattering windows and leaving dents in metal. Winds gusting up to 70 miles per hour bent street signs and tore shingles from roofs, adding to the widespread destruction and chaos. Tornado watches remained in effect well into the night, a stark reminder that tornado season can strike outside its usual time frame. Streets were eerily empty, lit only by flashes of lightning, as communities waited anxiously for the all-clear. The perfect mix of warmth, moisture, and powerful jet stream winds high above set the stage for disaster. Meteorologists noted that these ingredients, when combined, can turn an ordinary day into a nightmare for those in the path of the storm. For those in the path, the long road to recovery had only just begun. Neighbors and volunteers came together to clear debris, offer shelter, and provide comfort to those who had lost everything. The resilience of these communities shone through, even in the face of overwhelming loss. The heartland was left reeling from a terrifying weather event, its people forever changed by the power and unpredictability of nature. As the sun rose over the battered landscape, the true scale of the disaster became clear, and the journey toward healing and rebuilding began. What caused such violent tornadoes in winter? It's a question that left many meteorologists and residents stunned, as tornadoes of this magnitude are rare during the colder months. Typically, winter brings more stable air and less energy for storms, but this outbreak defied expectations and set records. To understand why, we need to look at the unique combination of atmospheric ingredients that came together on this day. It was a classic high-shear, low-cape setup. In meteorology, this means there was a lot of twisting and turning in the atmosphere, but not as much raw energy as you might see in a spring or summer outbreak. Yet, even with less instability, the setup was primed for disaster. CAPE, or convective available potential energy, measures atmospheric instability. There was some, but not extreme. CAPE is like the fuel for thunderstorms, and while it wasn't off the charts, it was just enough to get storms going. Sometimes, even modest CAPE can be enough if other factors are in place. The real driver was wind shear, winds at the surface from the south, but much stronger westerly winds aloft, creating a rolling motion in the atmosphere. This difference in wind speed and direction with height is what gives storms their spin, and on this day, it was unusually intense for winter. The jet stream was perfectly positioned, providing the spin needed for dangerous storms. It acted like a conveyor belt, pulling in warm, moist air from the Gulf of Mexico and slamming it into colder, drier air from the north. This clash of air masses is a classic recipe for severe weather. When thunderstorms form in this environment, their updrafts tilt the rolling air vertically, creating rotating supercells. These are the storms that can produce the most violent tornadoes, and they thrive when wind shear is strong. Supercells are the most prolific tornado producers, responsible for the strongest storms. Their rotating updrafts, called mesocyclones, are the engines that drive tornado formation. On this day, many supercells developed rapidly, each one capable of spawning a tornado. On this day, extreme wind shear compensated for modest instability, allowing many storms to rotate and spawn tornadoes. The result was a barrage of tornadoes, some tracking for miles and causing widespread destruction. The Storm Prediction Center had warned of strong, long-track tornadoes, and that's exactly what happened. Forecasters saw the signs days in advance, but the sheer number and intensity of tornadoes still shocked many. Early storms were discrete supercells, the most efficient tornado makers. These isolated storms had plenty of space to organize and strengthen, producing some of the most powerful tornadoes of the outbreak. As evening fell, storms merged into a line, shifting the threat to damaging winds. This transition is common in severe outbreaks, as individual storms combine into a squall line, bringing widespread wind damage, but fewer tornadoes. But by then, the tornadoes had already left their mark. Communities were left reeling, with homes destroyed and lives changed in a matter of minutes. The science behind the outbreak shows how a few key ingredients, instability, wind shear, and a powerful jet stream can come together to create chaos even in the heart of winter. Understanding these factors is crucial for predicting and preparing for future outbreaks. While tornadoes struck the Midwest, tragedy unfolded in California's Sierra Nevada. Near Castle Peak, a massive avalanche killed 8 experienced skiers, the deadliest in California's modern history. The group was well-trained and equipped, but the mountain's power proved overwhelming. The avalanche sent shockwaves through the backcountry community, highlighting the risks even for experts. Search and rescue efforts were hampered by relentless storms and whiteout conditions. Gale-force winds and heavy snow made recovery dangerous and slow. The high avalanche risk persisted, forcing repeated pauses in the search. This tragedy is a stark reminder. In the backcountry, nature is the ultimate adversary. One moment of instability changed everything. The deadly avalanche at Castle Peak was the result of a dangerously unstable snowpack. Think of the snowpack as a layer cake, strong layers on top of weak, fragile ones. Earlier, dry, cold weather created a persistent weak layer, like sugar beneath the surface. Then, storms dumped over 5 feet of heavy snow, forming a dense slab atop the weak layer. All it took was a trigger, a skier, a snowmobile, or gravity, for the slab to break loose. The resulting avalanche moved at highway speeds, snapping trees and burying everything in its path. Avalanche warnings were widespread, with hazards rated high or extreme. In Utah, officials triggered controlled avalanches to reduce risk after heavy snowfall. These weak layers can persist for weeks, making the danger invisible and unpredictable. The pristine snow concealed a deadly threat waiting for the right moment to strike. Oh, dry could sunshine, oh wine, aye. As the Midwest recovered and the West mourned, the East Coast braced for a major nor'easter. This winter powerhouse threatened crippling snow, fierce winds, and coastal flooding from DC to Boston. Forecasters raced to predict the storm's track and intensity, as millions prepared for possible shutdowns. Nor'easters feed on the clash between cold land and warm Atlantic waters, sometimes bombing out into explosive storms. Cities readied snowplows and salt trucks, while residents stocked up on essentials. The storm's timing threatened to paralyze Monday's commute, with power outages and coastal flooding likely. High tides and storm surge added to the risk for low-lying communities. Forecasting a nor'easter is notoriously tricky. Small shifts in the storm's path can mean the difference between a blizzard and a near miss. The American and European weather models showed drastically different tracks, leaving forecasters and the public in suspense. The American model predicted a direct hit with heavy snow for major cities. The European model kept the storm farther offshore, sparing cities from the worst. A closer track would mean over a foot of snow and days of disruption. Farther out, just a few inches of rain. The storm's path depends on the jet stream and high-pressure systems, making last-minute changes possible. As the storm neared, models trended offshore, easing fears of a crippling blizzard. Relief for some, disappointment for others, but a classic nor'easter dilemma. The science shows how unpredictable and impactful these storms can be. The week's weather chaos stretched far beyond tornadoes and avalanches. In Utah, a father was killed in an avalanche while snowmobiling, underscoring the widespread danger of unstable snowpacks. Resorts closed for avalanche mitigation, using explosives to prevent larger disasters. Meanwhile, a winter storm dumped over a foot of snow in Minnesota and North Dakota, creating blizzard conditions and dangerous roads. Highways became treacherous, with multiple crashes and long backups in freezing temperatures. The heavy wet snow made travel perilous for drivers. In California, the search for a missing skier ended in tragedy, compounding the week's sorrow. From deadly mountains to icy highways, winter weather created life-threatening situations nationwide. A week of wild weather is a powerful reminder of the need for preparation and respect for nature. We can't stop tornadoes, avalanches, or nor'easters, but we can reduce risk by staying informed and ready. Weather alerts save lives, giving precious minutes to seek shelter. Tornado-prone areas need designated shelters and emergency kits. Winter storm regions must stock essentials and prepare for outages. In the backcountry, education and proper gear are vital. Avalanches can strike even the most experienced. Always check forecasts, carry safety equipment, and be willing to turn back when conditions are too dangerous. This week showed our vulnerability but also our resilience. Neighbors clear debris, volunteers brave hazards, and crews work tirelessly to restore normalcy. By understanding the science, heeding warnings, and looking out for each other, we can weather any storm. Together, we face nature's fury with knowledge and strength.